Sir, shall we start?
Yes, we are live now. We can
Yes.
start.
Okay, good evening, everyone. A very warm welcome to all the enthusiastic sky gazers, astronomy lovers, and esteemed guests joining us across the country. I am Radhika Kayande. I'll be your host for today's session. We are on the third episode of this exciting journey of virtual sky watching series from Earth to the Edge. This series is a set of 9 interactive sessions where we explore the night sky together and learn about stars, planets, and wonders of space and grow our curiosity about astronomy. This exciting series is organized by Professor Rajendra Singh Science Exploratory in collaboration with National Astronomy Network of IAPT with the goal of making sky watching accessible and enjoyable for everyone. For today's session, we are honored to be joined by a passionate astronomer who will guide us through this journey, Mr. Aryan Saxena. Welcome, sir. Sir is a student of physics, master's physics, and he has done his bachelor's from Ferguson, Pune. He's completing his master's from NIT Harimpur. He has done lots of research and projects in various topics such as black hole perturbation theory, Horse triangle, mathematical modeling, and extending Heisenberg's uncertainty principle and various such topics. He has done uh, completed his various projects in gamma rays, also in theoretical aspects of gravitational physics. Also, he has qualified GATE 2025. Also, he has cleared IIT JAM exam with All India ranking 984. Also, he has cleared various international and national exams related to astronomy and astrophysics. Also, he has done various summer schools uh, in the subject of astronomy and astrophysics, and also quantum mechanics and thermodynamics. So, we are really very excited uh, to have you, sir. And I request you to start your session.
Thank you. Thank you for the very, very kind words. I would say that most of them were, I was at the right place at the right time. That's the only thing. But yes, I do love astronomy. Thank you. So let's start with this thing. So the title of my presentation, just a second, I'll just minimize this window. Yeah. So the title of my presentation is The Stars That Never Sleep, Finding Polaris and Circumpolar Constellations. I hope everyone's okay with Hindi and English because I'll be switching between the languages as per the flow of the presentation. So first of all, I would like you all to focus on this first page. So let us see what actually is this first page. Has anyone been reading up the latest news? The latest news in astronomy. Has anyone any clue about what this image in the background? This orangish pink colored image represent? Or which image is this? Like, has anyone read about it? So I'll give you a quick overview of what this is. This was one of the first light images of Vera Rubin Observatory, of which I am now officially a part, and I will be working with the data of Vera Rubin Observatory for some astronomical data handling. So let us stick to the topic for now. And the topic is stars that never sleep. That is finding Polaris and the circumpolar constellations. Circumpolar constellations are actually the constellations that never sleep. And how do we define if a constellation is gonna sleep or not? It depends if the constellation is setting or not. So the constellations which are very very close to Polaris and the neighboring area, they never set. That's why they circulate around the Polaris, and that's why they are called circumpolar constellations. And we'll be discussing especially about the Polaris, that is the pole star. So let's dive into it. Also, at the end of this session, there will be a small quiz for everyone. So if anyone's interested, we can have that thing. So the eternal beacon of the night sky. Stars, often referred to as the eternal companions for travelers, have played pivotal role in navigation, storytelling across cultures, and unwavering presence has inspired countless myths and legends, serving as constant reminder of guidance, wonder, and throughout human history. Most of us have definitely seen night sky, especially those who have been living in cities. They might not have seen how beautiful it looks from a remote location, but those who have been living somewhere near the outskirts have seen how beautiful the stars have been, and they have been of this beauty forever and ever. So we have been observing them and thinking about them from the beginning of the human history, I suppose, and we have been making stories about it as our favorite time pass, because there was once a time when we didn't have TVs and mobile phones to spend our time. That's why we saw stars and created our own stories. So stars have been a key component of our imagination and creativity. What but stars have not just been a part of our stories, they have also been a part of our navigation system, of our traveling system. How have we used stars in traveling? So one of the simplest one would be, as we all know, sun is a star. So as we all know, we have seen sun rise in the east, set in the west, and that is something which we have been using for a very long time. The location where sun sets, that is west. The place from where sun rises is east. So that is how we can use sun in the day. But what happens at night? We have stars. So that's not just one sun, that's a million of millions of suns at once. Ancient navigation tools. Stars have been utilized for navigation by travelers for thousands of years, offering a reliable source of direction in the dark. Just like sun, even stars rise in the east and set in the west, which are near to the equator. But there are some stars that actually never sleep. Their constant presence in the night sky provides comfort and orientation, especially in unfamiliar territories. So, no matter where you are, especially if you are in the North Pole, you'll always look up to the sky, and there will be a few constellations which you will be able to recognize without any efforts. You will just know that this is the constellation. For example, I recognize Big Dipper, I recognize Orion, I recognize Cassiopeia. No matter where I go, I see those stars and I know that this is somewhere I'm still on Earth and I haven't been abducted by aliens, to say it that way. Polaris, a guiding star. So, as we know, we can find out east and west, but then also we'll be thinking, how do we find the north direction? Polaris, which is known as the North Star, has played a significant role in navigation due to its supposedly fixed position above the North Pole. It has guided countless explorers and sailors across ocean and deserts for centuries, because you don't always have enough time to wait under the night sky to see stars rising from east and setting in the west. That's why what we do is we look at Polaris and we know this is north. And once we know which direction is north, then in that case our left hand would be west and our right hand would be east, and back of our head would be facing in the south, and that's how we can find our directions. Why is Polaris the guiding star? Polaris, which is also known as the pole star, is positioned nearly directly above the north pole, and that is because if we assume earth is rotating, so the axis of rotation, that is exactly aligned with the direction of Polaris. That's why what we see is, when Earth rotates, you will see just this part rotating, and this point will seem as if it's not moving at all. And that's where Polaris is placed. And to locate Polaris, we need to know a little bit about the night sky. So let's get into night sky, and I would request every one of you who is present in this meeting, who is watching this through YouTube live, to go out today, tomorrow, whenever the sky is clear, whenever you are in a nice mood. Just go out, look at the night sky, and try finding out these constellations, which I'll be explaining in this presentation. So first of all, is one of the main constellations that we use is Ursa Major, and using the pointer stars. So Ursa Major is this constellation. This is a pretty big constellation, but honestly, most of us have never even seen this structure in the sky. What we actually see is this star, this star, this star, this star, this star, this star, and this star. So this is also called as a very, very famous name in Hindu mythology, that is the Saptarishi. This is the Saptarishi, and there's also a binary star here, that is Alcor and Mizar. Binary star is nothing but just two stars rotating each other. So this is a binary star which is very interesting to observe with a binocular or a small telescope. Another way to confirm the direction is using Cassiopeia. This W-shaped constellation is called as Cassiopeia. Also, one of the most interesting thing in this photo is presence of this galaxy. What we see as a blob of dust, it's Andromeda galaxy, a somewhat similarly sized galaxy as ours, which is just above our head and just looking at us, and we can see it very clearly with a small binocular if we are on a dark enough location. So this constellation is also used to find Andromeda galaxy. And how do we find Polaris using Ursa Major? That is, we connect these two stars and we extend the line, and somewhere over here we'll find Polaris. Facts about Ursa Major. Ursa Major, this is the shape that we observe, the Saptarishi shape. Ursa Major, also known as the Big Dipper, which is pretty commonly seen by most of us in the north direction, is a prominent constellation with a shape resembling a large saucepan. This is the handle and this is the saucepan. The unique shape makes it one of the most easily identifiable constellation in the night sky, and that is why it is very easily observable. This is the Saptarishi. Navigational importance. Ursa Major plays a pivotal role in celestial navigation as its pointer stars help guide observers to Polaris. Using this constellation itself, we can find Polaris. And this helps us identify where Polaris is. There is another constellation known as Ursa Minor, which includes the Polaris itself. I'll be coming back to that point later on. And this image which you see, this is the Milky Way itself. The galaxy which we live in, this is how Milky Way looks from the dark skies. And this is also, I won't say that you can look at this image exactly the way it is in a real case, because what this image is, it's done by astrophotography, which includes multiple methods. That's why we use Ursa Major as one of the major constellations to pinpoint Polaris. Ursa Major has also been a part of many stories because some people think a saucepan looks like a bear. This is the bear that we think Ursa Major is, and this is what has been included in most of the mythologies. See, this is the binary star I was talking about, Alcor Mizar. This is Eliath. This is the pan shape. This is the handle of the pan. This is the pan itself. Connect this star, this star, this star, this star, this star, this star, and back to this star. So what you see is a pan-shaped constellation, which is the Big Dipper. Other stars are present, but the thing is they are very faint to be observed by us in a regular case. Ursa Minor, the Little Dipper. This is Ursa Major. This is exactly how you can look at it. And this constellation, this is Ursa Minor, the Little Dipper. Right over here is Polaris, and along this, the Earth rotates. So imagine. Yes. Is there any doubt?
हिमाचल प्रदेश वरून तो स्पीकर आहे.
Yeah. So this is Polaris. So there's an axis going right through it, and along that axis the Earth rotates. That's why what we see is Polaris being still in the sky. especially in the northern sky. Southern hemisphere of the sky won't be able to see Polaris itself. So Cassiopeia, the W-shaped guide, and the Ursa Major, a navigator's companion. So this is Ursa Major. This is the part that we look at. Most of these concepts have been covered already. This is Big Dipper. This is Cassiopeia. And this is Polaris. That's how we locate Polaris. So we connect these two stars and we draw a line and we point at Polaris. And we connect. This is Cassiopeia. If between Big Dipper and Cassiopeia lies Polaris. Also, Cassiopeia can be used to locate Andromeda galaxy. If we create a W, the bigger arrow which is present over here from this point to this point, this will, if we extend this right over here, we'll be looking at the Andromeda galaxy.
Sir,
Yes, is there a doubt?
yes, sir. How do we, how do navigators find their way if it's a starless sky?
Usually there are some ways to find their ways even in starless skies are very rare until unless there is a case of there's a case of rainy weathers, and that in that case sailors won't actually sail because it's rainy weather, so there would be a very high chance for storm. So usually they sail on the nights where they know when they know the direction. But even if they didn't know, we had learned about compasses from a very long time. Also, there are some ways to statically charge a piece of pin, place it on a leaf, and the pin will align slowly in the direction of north. That is a nice way which can be done in case of starless skies, but skies are pretty reliable sources, and people usually sail on the nights where it's a starry sky. That's how we do it. But also, what this thing was prevalent around 400 500 years back. Later we invented compasses and we created different kinds of navigational tools. Now everyone has Google Maps, even sailors, so they just use Google Maps. Okay, so coming back to our slide, I hope your question is answered.
Excuse me, sir.
Yes.
Is Polaris a part of Ursa Minor?
Yes, it's a part of Ursa Minor. I guess I showed you a. I'll just come back to that thing. So yeah, so you can see here the end of Ursa Minor is Polaris. If you, can you see my can you see this slide?
Yes, sir.
Yeah, this is Ursa Minus. This is Ursa Minor, and Polaris is a part of it. So coming back to circumpolar constellations. So what are circumpolar constellations would be the first question, because it sounds very fancy. And honestly, it isn't that fancy. It is just the constellations that are visible all year round, never dipping below the horizon. That is never going down our vision line. That's why, so that includes Ursa Major, Ursa Minor, Cassiopeia, and everything that is around Polaris. So anything that is around Polaris, for example, if I take my phone, if I show you this side, or actually I'll show you my charging port side. I hope my charging port side is visible. So assume this is Polaris, and if I rotate my phone, my charging point will be visible, and these speaker grills and my audio jack would also be visible, because these are the circumpolar constellations, which even if I rotate, this won't be going away from your side. So if I do this way, so there can be constellations that will be going away and coming close to your side, but anything that is close to the axis of rotation will be always be visible. Those constellations are circumpolar constellations. These have been key navigational aids because, as we know, they do not move around a lot, and that's why they are called circumpolar constellations. And that's why we have been using them, because no matter what day, what time of the year, or what season it is, they'll always be up there in the sky, telling us the right direction. Cultural significances. Now, this is a interesting part. which has a lots of stories in different mythologies, such as Cassiopeia and Draco are some of the other constellations which are also circumpolar. And these have been in our stories and mythologies for a very, very long time. I'll be coming to that part very soon. Till that, finding directions using stars, Polaris serves as a reliable guide for locating north in the night sky. That is, I told you why we can point to north using Polaris. Of stars, you can deduce the direction of east and west. South will always be found directly opposite near your head, towards the head side. If your nose is pointing towards Polaris, your left hand would be in west and your right hand would be in east. South will always be found directly opposite Polaris, allowing for effective navigation using the stars, and that's how you figure out all four directions. And once you know all four directions, any map, any basic printed map, you can use the directions and predict which direction you want to go. And okay, I'll be coming to cultural significance of Dhruv Tara, but before that is Polaris. But before that, I would like to tell you some fancy stories. Also, I'm a big fan of Marvel movies. Some of you might have seen the web series called Moon Knight. And in that, even there's a scene where they recreate the night sky. The main lead of the series, they recreate the night sky, which was present around 3000 years back, to pinpoint a location. That is how people have been using these constellations for a very long time. Even in deserts, the constellations are very, very useful tool. Your compasses might fail because of some magnetic anomalies, due to some magnetic fields, due to some magnetic rocks present, but the stars will never ever fail you, and they'll always tell you the right direction. So coming back to the presentation, cultural significance of Dhruv Tara. Myth of Dhruv. In Indian mythology, the tale of Dhruv illustrates unwavering determination and devotion as he strives to seek the truth and secure a place among the stars. This narrative underscores the significance of Dhruv Tara as a symbol of hope and perseverance. I would like to ask you all, has anyone of you heard any stories about Dhruv Tara? I have my story ready, but I think it's becoming very one-way kind of communication. So, is there anyone who has heard any stories about Dhruv Tara? The forum is open to answer any stories if you know about it. Okay, Kanak said no. Is there anyone who? Okay, there are no story. Is there anyone who has heard any stories of Dhruv Tara? Okay, I suppose there is no one. So I'll okay, I got it. I'll tell you the story of Dhruv Tara as per Hindu mythology. So there was very, very long ago, there was a king called Uttanpath. Uttanpath. Yeah, I suppose I'm pronouncing the name right. He had two wives. Two of the wives were Suruchi and Suniti. Suruchi was the younger wife. She was the second wife, and she had a son named Uttam. And Suniti was the elder wife. She had a son named Dhruv. But Suniti was older, so as per the king, he did not like Suniti a lot because she wasn't the most beautiful woman. But Suruchi, she was as beautiful as the goddesses themselves, and that's why the king fell madly in love with her, and that's why he always favored Suruchi. So when because he loved Suruchi, that's why he was kind of bound to love her son, that is Uttam. Is there any doubt? Can you please mute yourself? Yeah. So Suruchi and Suniti. Suruchi had the son Uttam, and as she was beautiful one and she was the more loved one, the king preferred Uttam over Dhruv. So one day when Dhruv was around 5 years old, King had Dhruv in his lap, and that time Uttam came in the room crawling, and King saw him, and suddenly he had the urge to pick up Uttam and kept Dhruv down, which made Dhruv very sad. And after seeing this, Uttam's mother Suruchi came to little boy Dhruv. King loves me more, so if you want to be loved, you should have asked God to be born from my birth, from me. You should have asked God to give me as your mother and not your original mother. This thing broke Dhruv's heart very badly, and he went to his mom and told her कि ऐसा ऐसा हुआ है mama मेरे को ऐसा बोला उन्होंने. So what, her mom was older, so she was also mature. So what she told him was, it's okay son, what you have to do in this case is just wait and pray to God, and he will, God will always be there for you. Pray to him and he will help you, and he will take all your unhappiness and make your life very fulfilled, kind of thing. And this thing stuck with Dhruv, and the 5-year-old Dhruv left the house and went to pray to God. On the way, he was very determined, so determined, came came on the way to stop him from going ahead. But he was so determined that even Narad Muni couldn't convince him to stop. So he went into praying to God Narayana, that is Vishnuji. He started praying to him, and he prayed for months. No matter what was the condition, he prayed without any food or any drink. He just sat down and prayed to God continuously, and his prayers were so intense that earth, heaven, and hell, all three shook because of his devotion. And he was alarmed and he was confused. Who is this kid? Who is this 5-year-old kid who has been praying to me for so long? And what does he want? I have to fulfill his needs. So that's why this is a story of unwavering determination and devotion. Just a second, I'm throat hurting. Yeah. So that is him and asked, "What happened, my son? Why are you praying to me this much? What is that you want?" And he told him that he wanted a place where no one could remove him from, and a place where he is well respected and he will not have to change. And that's when Vishnuji granted him in the sky, right at the axis of rotation, and you will be Dhruv and you will always stay in the north. And he was so determined that even the gods themselves gave the Saptarishi as his guardian. So the Saptarishi, that's why, came very close to North Star, and they acted as a guardian. So what we know from the mythology, it is said that even the Saptarishis can move, but the North Star never ever moves. That is the power of North Star. That is the power of unwavering determination and devotion. Just a second. Yeah. So that's how the young kid Dhruv became a guiding star. Dhruv Tara is often viewed as guiding star, serving as navigational aid for travelers in ancient time. Its steady position in the sky symbolizes reliability and guidance which was given to him from God themselves, and which he has been giving to us and all the sailors and all the travelers from the starting. Symbol of resilience. Significance of Dhruv Tara extends beyond navigation. It serves as a metaphor for inner strength, resilience in the face of challenges, inspiring countless individuals across generations to travel, to look out in the night sky, and to know that even if you want something, that is how mythologies have been telling us. I don't believe a lot in mythologies, but mythologies have been moral stories for us. They have been telling us that if you believe, if you have devotion, and if you are determined, you can achieve anything. and that's how the kid Dhruv achieved its unmovable position in the night sky, and so can you all achieve some immovable things. And for the case of physics, the unmovable thing would be Nobel Prize in Physics. Okay, I suppose a bad joke. Uh, so I'll just give a quick recap. Polaris serves as the North Star, providing a reliable point of reference for navigation. Ursa Major and Ursa Minor are essential for locating Polaris, while Cassiopeia aids in confirming its position. The circumpolar constellations, that is, the constellations that never ever go down, are visible throughout the year and never going below the horizon. Additionally, Dhruv Tara symbolizes guidance in Indian culture, emphasizing the enduring significance of stars in both navigations and mythologies. Okay, let's play a small game. Is there any stories related to the night skies you guys have heard? Any stories? I'll open the chat if there's anyone. Yeah, Uttanpad. Yeah. Okay. Am I lagging? Like, is there an issue with my internet? Uh, I okay. Is my voice breaking?
No, sir.
Okay. I suppose uh, there are some kids in the. Okay, it was breaking in between. So, is there any slide that you guys want me to repeat? So, I'll quickly go through those slides as well.
Sir, the story of Dhruv Tara
Okay,
was not playing that time, the audio.
okay, okay. I'll retell the story, I suppose, in the art case. So, through I'll quickly go through it because I guess some people have heard it, some people have not. Okay, I'll quickly go through it. Uh, so there was a king. Okay, some kid had told me the exact name. I'm very bad with pronunciations. Uttanpad. Uttanpad. Yeah. Uttanpad was a king who had two wives, Suruchi and Suniti. Suruchi was the younger wife, and she was the more beautiful one. And she had a kid called Uttam, whom the king preferred more than the older wife and her son, that was Suniti and Dhruv. And that's why Dhruv decided that he wanted a position. And Dhruv, as per his mother's instruction, listened to those stories, listened to her advice of worshipping God and being a very devotional person. And that's how he decided he will be a devotee. And he went in the jungle and prayed for 6 months. And that's when Vishnuji came to him and asked him what was that he wanted. And that time he told that he wanted to be placed at a good enough position, at a respectable position where where he shouldn't be moved from, as he was moved from the position that where he sat in his dad's lap and he was replaced by Uttam. So he didn't want that to happen. So he wanted a position which was fixed only and only for him. And that's why he was placed in the sky right at the axis, known as the Dhruvta, and he became Dhruvtara and he was placed at the Polaris. And the Saptarishis were placed around him, as we can see in this image right over here. The Saptarishis were placed around him to protect him. And it is said that even the Saptarishis move, but the Polaris never moves because that was what he had asked for. Yeah, I suppose the story is clear. Is there any doubt in the stories? Was my voice okay? So sometimes my network lags.
Yes, the story
No,
was clear.
sir, during the start, you were lagging for like 2 to 3 seconds.
Okay. Is there any part that you missed because of that? Not. If
No,
not,
sir,
then I'll
no,
move
sir.
ahead. Okay. I have a short quiz for everyone at the end as well. Okay, so that was the mythological side of it. Just a second. Okay, I'll quickly end this thing and then we'll have a quiz session. So outdoor stargazing activities, that was the thing I was saying, that we should go out and we should look at the stars. The stars are very, very beautiful thing to look at, especially in a clear night with a not you don't need a telescope, you don't need anything. You just need your eyes and a very clear sky and look at it. And there are millions of stories that you can create for yourself. You can create millions of characters in this night sky. And if you guys know about the app called Star Walk, there are also constellations called Iron Man constellation. There is Hulk constellation. Is a Thor constellation as well. But that is asterism. Those are not actual constellations. But yeah, those are just stories which you can create, because these are just stories, and night sky is purely based on your imagination. It's as beautiful as your imagination can make it. So outdoor stargazing activities allow participants to experience the night sky firsthand. They can identify Big Dipper, Cassiopeia while locating Polaris. And indoor also, when there are days where you can't actually see it, you can use virtual stargazing sessions. Indoor learning about constellation relies on visuals and theoretical knowledge. While informative, it lacks immersive experience. That is true. You can't actually learn about constellations while sitting in a classroom. You can know about the constellations, but you need to go out in the night sky, feel the night sky. You need to experience the beauty of the night sky. And that's when you know that you will fall in love with astronomy for sure. So, okay, now everyone's favorite part, Q&A session. Now, if there are any doubts, you can ask me.
Yes, sir.
If there are, yeah, okay. Okay, well, one by one. I suppose uh, every one of you can mute yourself and one by one ask questions. Okay, yeah, let's start with questions.
Okay, raise your hand and you can ask your question. Okay, Omkar Vaidya, you can ask your question.
Thank you, ma'am. Sir, what would have happened if in ancient times the Dhruv Tara exploded into a supernova? What would have happened?
That's a very, very good question, I would say. The thing is, Dhruv Tara didn't explode. That is something very different. Why it didn't explode? That is because it's not old enough yet. And why? The thing is, Dhruv Tara has been created into stories, and if Dhruv Tara wasn't there, we would have used other constellations as a source to locate. And there are other ways to navigate as well. Okay, is my voice echoing?
Yes, sir.
Someone said,
A bit.
am I audible? Yeah, is my voice clear now?
Yes, sir.
Yes, sir.
Okay, yeah. So if Dhruv Tara wasn't there, we would have looked at Cassiopeia and we would have looked at Big Dipper and we would have assumed a point. That's what we do in the southern hemisphere, because there is no pole star in the southern hemisphere. So we take average of constellations and we imagine that this direction, if there are two constellations present over this area, so we'll just assume that this area has to be the polar region. And that's how we do it in the southern hemisphere, because actually we are just lucky in the northern hemisphere to have Dhruv Tara at the Polaris to locate the North Pole. Any other questions? I hope I have answered your question.
Yes, sir.
Yeah.
Yes, sir. There is a question.
Yes, please.
In some cities like Delhi, Mumbai, and Pune, there we can't see this sky constellation because of the pollution which is there in the sky. So, how can we see the constellations?
Okay. As you said about Pune, I am from Pune. So yeah, I know what I have been doing was I lived in a slightly outer region of Pune. I lived near Katraj side. That's why I could see constellations. But if you live near the Magarpatta area, especially I'm just talking about Pune, if others don't get it, I am just meaning that I lived somewhat out towards the outer side of the sky, outer sides of the city. That's why I saw constellations. But if you can't see, whenever you go on vacations, whenever you go to your nani's place or your dadi's place or somewhere away from the city, or if you go for long drives, that time you can just look up in the sky and you can find out constellations, because light pollution is a thing that has been bothering most of the astronomy people a lot. And that's why when you actually have to study the night sky, you actually have to go to somewhere far off from cities and lights. Yeah. I hope I have answered your question, Kavya. Kavya, right?
Yes, sir.
Okay, I hope I have answered your question.
Yes, sir.
Is there any other question?
Okay, now Manan, you can unmute yourself.
Yes, thank you, ma'am. Sir, you said that the Dhruv Tara would not is too young to explode. So, what if the surrounding stars exploded into black holes and then sucked the Dhruv Tara? Because that can happen with stars. And if it did happen, did the Saptarishi protect?
Okay. That's a. I like how. Sorry, but I'll just say this. This is a very cute question. And as a kid, even I was very impressed, fascinated by black holes. But now that I study black holes don't form that way. That's not how they form. And probability of any black hole forming near Dhruv Tara is very low. Also, the average distance between two stars is very large. So even if there was a black hole right over very close to Dhruv Tara, the chances are of that black hole interacting with Dhruv Tara would be very low, because the average distance for Milky Way between two stars is around 4 to 5 light years. So 4 to 5 light years, you can convert it into kilometers, but yeah, that's somewhat 10 to the power 10 kilometers, I suppose. Yeah, somewhere in that region. So there would be no effect. Is that a good enough answer?
Yes, sir. And there was another question, sub question,
Sure.
that if it actually like appeared very near, a black hole actually formed very near to Dhruv Tara. You said that Vishnu put Saptarushi there to protect it. So I was asking how would it protect?
Okay. So Saptarishis. Okay. So Saptarishis were put as per mythologies, and I don't think Hindu mythology or any mythology at that time was advanced enough to have the concepts of black holes. But yeah, Saptarishis are just a name for the constellation. Those are just stars, and honestly, stars can't protect other stars. Also, what you see as constellations is actually just a bunch of stars that are placed randomly, very far from each other, and that's our imagination that is assuming कि हाँ ये saucepan बन रहा है. This is a bear-like looking constellation. Oh, like someone is speaking. Excuse me, can you just mute yourself? Okay, I'll just answer his question, then I'll get back to you. Yeah. So Manan, I suppose I have answered your question.
Yes, sir.
So yeah, so they don't actually protect it, but that's what mythologies say.
Okay, now Ananya, you can unmute yourself.
Sir, why is Dhruv Tara always stable? Means why it's not moving like other stars do?
Okay, so that's a very nice question. I suppose I explained it, but I'll explain it again. So can you see my phone right now? I'm holding my phone very close to my face.
Yes, sir.
So can you see the charging port?
Yes, sir.
So assume this hand is the horizon and this is my phone. So anything that is, I'll rotate my phone about the charging port itself. So this point, which is very close to the axis of rotation, that is the point which you will constantly see. I think I can explain you better. Just okay. I have this box of sketch pens. So, um, can you see this black colored belt?
Yes, sir.
If I rotate it, so that around the about this black colored belt, so anything that is lying very close to the black colored belt would actually seem to appear relatively stable as compared to the whole, as compared to this cap. So assuming when this cap goes down, you can't see anything, and when things come up, you can see things. But if you think anything that is very close to the axis of rotation, you'll always see these things. Do you understand it, or should I explain it more? Like, I don't know.
Sir, I didn't understand it.
Okay, I'll try to explain it in simpler ways. So, do you know about axis of rotation? And do you
Yes, sir.
understand the word? Do you understand the word axis of rotation?
Yes,
So,
sir.
okay, just a second. Huh? Can you see this pen?
Yes.
So, assuming there's an axis of rotation right over here, and if I rotate this pen, so when the pen goes below my fingers, the pen is below horizon and you can't see it. Okay, and when it is above the finger, you can see it. Do you understand till this point?
Yes, sir.
So if I place pen somewhat higher like this, and if I rotate it, so anything that is very close to the rotational point, the point about which it is rotating, that would seem to move very less. That's why, and Dhruv Tara is placed exactly at the point of rotation. And all the circumpolar constellations are placed very close to the point of rotation. And that's why they never seem to actually go out of below the horizon. Do you understand it?
Yes, sir.
Okay, that's great. I hope I have answered your question. Are there any other questions?
Yeah, there are two more questions.
Yeah, I suppose we have time for them.
Yes. Okay, Shaurya Pujari. You can unmute yourself.
So I have the question that Polaris appears below the horizon in the southern hemisphere. So how do the people locate their location or guide themselves in the southern hemisphere?
That's a very nice question. So southern hemisphere doesn't have any particular star exactly pointing in the south pole direction. So when people are in the southern hemisphere, they actually can't locate themselves. So what they do in that case is they take two constellations which are close to the South Pole. I don't remember the name of those constellations exactly right now, but they take two constellations and then they see that they are rotating about a point, and the point around which they are rotating, that's that point they assume that this will be the South Pole. So they don't actually have a proper navigation method. This navigation method only works in the northern hemisphere.
Okay, sir. Thank you.
Well, you can yeah, one more question, I suppose.
Yes, Jeet Chelani.
Thank you, ma'am. Sir, actually, can we that North Star is located in the North Pole, na? So, can we derive the tilt of the Earth by that by observing just the North Star or Dhruv Tara?
I don't know if we can derive the tilt of the Earth, but I suppose you can find your latitude from that. You can easily find your latitude from that. So if you have used a telescope that has a equatorial mount, you actually have to point it in the direction of North Pole to define your latitude itself. So yes, how above the horizon North Pole, North Star is okay. Yeah, someone answered in the chat. Octans and Apis are the constellations. Yeah, I suppose yes. 99 point. Yeah, I suppose you are right. Those are the constellations of the southern hemisphere. Thanks to Omkar. Yeah, coming back to your question, G. So yeah, how high it is from the horizon? How high it is from the horizon? From that you can predict at what latitude you are. For
Okay,
that you'll actually. Yeah.
And sir, can we say about that if the North Pole is facing towards the Polaris, so can we say that the distance, if it is less, so can we say that it is summer, it is winter, it is any season, it is like that?
Sorry, I didn't get your question. Can you repeat it?
Yes, sir. See, this is the location of the Polaris is fixed, and our
Yeah.
Earth changes its tilt. Sometimes it is towards the sun, and sometimes it is towards the sun and away from the sun, the North Pole or South Pole. It's alternative. So
Yeah.
can we say that in the North Pole? So by observing the Polaris. So can we say that which season is going on, summer, winter, in South Pole or North Pole? It is like that.
No, actually, not really, because that's why North Polaris is called a constant star, because no matter what the season is, it will always be in the sky. But there are other constellations which you can look at and you'll know what season it is. Also, but the thing is, if you're talking about the relative motion of the star because of Earth's tilt, it's very, very low, because the distance between Earth and Dhruv Tara or the Polaris is way too huge. So, it very minor fluctuations would be nearly negligible to the human eye. But from the stars that are present in the night sky, from that you can easily predict what season it is. So there's summer triangle, there's winter triangle, there's Orion constellation. Orion, I'll be coming to that thing. Orion constellation is one of the most important constellations of the winter night sky. Is that a good enough answer?
Yes, sir.
Arrange,
And
we
one
can
more
make it
question.
bilingual also. We can address in Hindi also.
Okay, sir. Okay. Uh, okay. Now everyone has asked me question. Sir, Hemant sir.
Yes, sir.
Now I'll be taking a small quiz, and I know you know all the answers because you are also a fellow astronomer. So I would like to keep this thing restricted to the kids.
No,
And if
you are right. But we can take some question in Hindi also, and we can address so that students can be easy and comfortable to ask their question.
sure,
And you
sir.
can also answer in Hindi so that they can understand better in
Okay, okay.
your expressions. Yes.
Sure, sir. Yeah. So again, if someone has questions Hindi में तो फिर I can answer in Hindi as well.
Yes, yes.
Okay. So two participants raised hand. Okay. Yeah.
Yes, two, three
Okay.
students have raised their hands. So, Tejasvi.
Sir, I wanted to ask that does Dhruv Tara shine the most?
नहीं, Dhruv Tara is in the brightest star. I suppose it's somewhat the 15th or the 14th brightest star, but no, it is not the brightest star.
Okay, so sir, which is the most brightest star?
I suppose it's Vega. I suppose it's Vega.
Okay, thank you, sir.
Also, if you're talking about the brightest star, yeah.
In the sky, visible sky.
Yeah,
But
Sirius.
otherwise,
Brightest star is Sirius.
But otherwise, winter most visible and brighter sky is
आवाज पण येत नाही इकडून तर
Sirius of Canis Major constellation. But it is the biggest, and otherwise in magnitude it is VV Cepheus. But it is so far that we cannot see even with the naked eye. It is very bigger than the sun and very bright, but it is not. It is at a large distance, so in a way that we cannot see it with the naked eye. It is in the Cepheus constellation near North Star. But visibly, you can say Vega and Sirius. They are the bright star in winter.
Yes.
Nowadays, if you wake up early in the morning at 4 and 5 o'clock in the morning, you can see both of these stars. Yes. Arians,
Yeah,
next
there are,
question, please.
yes, there are a few more questions. I'll quickly take them. Ma'am, can you unmute the participants as per the questions?
Yes, Chavi Thakre.
Yes, sir. I was just asking that the Polaris is a circumpolar star and on the Earth, but what if we try to view it from Uranus or some other planet? Will it be the same?
No, that it is not. And Polaris is the circumpolar star right now, but there's also a thing called precession. So after about a few hundred, a few thousand years, Polaris won't even be the circumpolar star. So yes, it's circumpolar
Polaris,
star. It is.
Polaris is
Sorry?
not circumpolar. Polaris is a star, but the constellations which move around the pole star, that is Polaris, they are called circumpolar constellations. They are circumpolar because they never set. They are all the during entire year you can see they are circumpolar. Polar mean they are moving around the Polaris. So Polaris is the star on the axis of rotation, and all those constellations which never set during the year, they are called circumpolar constellations. And Polaris and North Star is the same thing.
Yes, sir.
Is that
Thank
okay?
you, sir. Thank you for the correction, sir.
Yes, any
Yes,
other question?
Tejas, you can unmute
Yes, sir.
yourself.
Sir, my query is that what is the approximate distance between Earth and North Star?
I'll have to search that quickly. It's a few hundred light years.
It is, yes, sir. It is few light years, few hundred light years away. Yes. You're right, Arya. Go ahead, please.
Yeah, it's around 432 light years.
Okay,
If
sir.
you want to know the exact number, it's around 432 light years.
Okay, sir. Thank you.
Welcome. Any other questions, or should we go to the quiz section? There's a small quiz I have planned for you all.
Okay, we'll take just last question and then we'll
Sure, ma'am.
shift to quiz. Okay?
Sure, ma'am.
Arav Kamre.
Sir, which one is brighter? Series A or Series B?
I suppose it's Series A. I suppose it's Series A.
What is the question?
Which is brighter, Series A or Series B? Yeah, Series A is the brighter one. Series B is the fainter one.
Thank you, sir.
Welcome. Okay. Okay. Now, you all guys have asked fabulous questions. I loved your questions. Now it's time for me to ask you guys some questions. Let's have a small quiz. Sadly, there won't be any awards or chocolates for this question, but I suppose it will be a little fun. Are you guys ready for quiz? The chat. Answer in the chat.
Yes, sir.
Okay, perfect. Let's go.
Just a second, sir. I just want to
Yes,
ask
yes, ma'am.
that everyone needs to answer in the chat box only, na?
Yes, ma'am. It would be easier for us because,
Yes.
like, there will be otherwise we will have to mute unmute a lot of times.
Yes, right.
Okay, let's go to the quiz section. Just a second, my computer. Yeah. Okay, so the thing is, I have taken some photos of the night sky, and I'll be showing you those photos, and you have to tell me which constellation or which of the prominent feature is visible in that constellation in that photo. So I would recommend everyone to raise their phone's brightness to maximum because are gonna be a little faint. So if you have the answer in the chat box, and I'll if you know the answer, I'll answer in the chat box. Otherwise, I'll tell you the right answer because sometimes even I can't identify these things. So we have the first image. Can you guys see the image? Can you guys tell me which constellation it is? Okay, answers yes, perfect, perfect, yes, Saptarishi, Big Dipper, yes, perfect. Okay, good. You guys are smart. You guys are really smart. Damn, everyone's smart in this group. I thought this quiz would be a bit hard. Okay, damn. Everyone is smart. Okay. Translation is this. Okay, translation as well. Now. Okay, the first answer is from Atharva, Jeet, Omkar, Arnav. Okay, that's a lot of people. Yes, bingo. Wow. Okay. Okay. Uh, okay, a bonus question. How many of you guys in Orion constellation? Orion constellation, which is this red star. It's okay if you mess up the spelling, even I don't know the spelling. That's totally fine. Yes, perfect. Okay. Not Polaris. Yes, Betelgeuse. Yep. Extra points for people who know the right spelling. The right spelling. Okay, yes, that is Betelgeuse. So this star is Betelgeuse. Okay. 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 Perfect. Let's go to the next constellation. This is a hard one. Okay, this is a hard one. This is a star cluster. I'll give you a clue. This is a star cluster, and you actually need some form of optical aid to look at it. How many of you can tell me which is the star cluster? Okay, Betelgeuse done. I've changed the slide. Is there anyone who knows which is the star cluster? This is a very, very beautiful star cluster. Messier, okay. Messier, it's a Messier object. Messier is a list of objects. So Messier, no. Saffron, no. I don't know. Okay. Yeah. Anyone? Okay. No problem. You might actually need a binocular to look at the star cluster. Yes, there are 110 Messier objects. Okay. We are sorry, but we are not. Hades, no. How many of you have heard the name Pleiades? This is the Pleiades star cluster. Athena, nahi, I don't think it's called Athena. But yeah, this is Pleiades star cluster. It's a very, very famous star cluster, and it is famous because of its blue hue. So if you have time later on, you can just look at this thing on internet. I'm typing. I have sent you the right name for this. That is the spelling. I suppose that is the spelling. You can search for it, and you will get Pleiades. And this is the Pleiades star cluster. It's a very famous one and very bright and visible one as well. Okay, coming to next thing. Okay. Okay, now we have another constellation. Which constellation is this? A clue is it is very close to the Milky Way galactic center that is in the night sky. Which constellation is this? I'll just pinpoint this thing. No, not Cassiopeia, not Hercules. Scorpion, yes. Who said Scorpion first? Okay. Okay, yes, this is Scorpion. Okay, Omkar Vaidya, Tejas Javanjwal. Okay, perfect. Yes, this is Scorpion. So this T shape is the scorpion, and this is its tail. Okay, yes, this is scorpion. So this whole thing is called the scorpion, and this is actually used for pointing to the Milky Way in the night sky, and somewhere around this area is Milky Way. I don't think it's visible in this photo, but okay. 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 Now another one. There are two things in this. You to find which two constellation. There is a constellation and there is a star cluster. So can anyone tell me which star cluster and which constellation is present? Messier is a catalog, by Manan. Messier is a list of objects. It's not a real. It's not object. Messier is a list of objects. Okay. Okay, I'll pinpoint the SWORD catalog. Suppose that would be a catalog, but yeah, catalogs is a list of objects. It's like it's not actually an object. Okay, I'll pinpoint the constellation. This is the constellation, this Y-shaped constellation. Can anyone guess? Okay. Okay. No, catalog is a list of objects. We're talking about constellation, right? Okay. Can anyone guess? Is there anyone? Okay. W, no, W is not yet here. I'll come to W after a while. Okay, Ursa Minor, no. Okay, how many of, like, say, Taurus? How many of you have heard the name Taurus? Yes, Taurus. There's a person who said Taurus. That is Vedika. Vedika, yes, it's Taurus. Yes, Kanak, yes, Taurus. In Hindi, it's मेरे को मेरे हिंदी के नाम ज्यादा याद रहते नहीं है. So, but yes, this is Taurus, and this thing which you see, this fuzzy little spot, this is Pleiades. This is Pleiades. This is exactly the constellation which I showed you guys earlier. Yes, this was Pleiades. I had shown a picture of it before as well as a star cluster only. This is a zoomed out version of it. This is Taurus. Okay. Okay, come and now we are going slightly towards the harder section. Okay. I'll give you all a clue. Can you see this fuzzy spot where my mouse pointer is kept? Very close to that place. Can you see a fuzzy spot? It's a thing which I had mentioned in this lecture itself. And it's very close to Cassiopeia. What is it? Rus Major? No, not Rus Major. Not Ursa Major. Not Polaris. This fuzzy spot is something. Yes, Andromeda. Yes, sure. Yes, that is. Yes, Andromeda. This is the Andromeda galaxy. Yes. Okay, Siddhant. Yes, yes, Andromeda galaxy. Yes, this fuzzy spot which you see, uh, this is Andromeda galaxy. This is exactly what Andromeda galaxy looks through binocular, I suppose. Yes. Okay, a simple question. Yes, left is Cassiopeia. Actually the image is a bit zoomed in, so Cassiopeia isn't image. That's why I didn't show that one. Okay, a relatively harder one. This is also not the best photo of it you can see, but you can see some light and dark bands here. Galaxy, and this is very close to Scorpion. Which galaxy is it? It's very close to Scorpion, and this is our home. This is the place. This light and dark band which you see over here. This is what we call home. Yes, Omkar. Yes, it is our lovely, lovely Milky Way. Milky Way. This is our lovely, lovely Milky Way. This is what we call home. And I suppose there is a last. Okay. Okay, no. Okay, this was the last one. Congrats to everyone who got the right answer. Also to the people who didn't get the right answers, because it was great having, I suppose my images were decent. I am not the best astrophotographer, but this was just some basic images that I had taken. So congrats to everyone, and special shout outs to writings. Guys, I'm very, very thankful to you all. Okay, so coming to thank you slide. And I hope you guys go out in the night sky, look at it, enjoy the night sky, and see what nature has given us. I suppose I have winded up in time. Sorry, I took 10 minutes extra. That was because of the quiz. Sorry for that. Uh, so do go out in the night skies to you all. And that's where I ended. If there are questions, you can ask me. Otherwise, I'll just take a leave. Okay. Thank you, guys. Thank you, everyone. Thank you for being such a good audience. You guys have been very, very calm, and you guys had lovely questions. Okay, there is a question. Mayuresh. Ma'am, can you
Sir,
Yes.
sir, my question is that my one friend always tell that Pomper A is the biggest black hole. Is it correct?
Which is the biggest black hole?
My friend always says that Pomper A is the biggest. Is it true?
I don't know which is the biggest black hole. I just searched it. Tan 618. There's a very big black hole in the center of our galaxy, that is Sagittarius A. But yeah, I don't think there's any black hole named Pomper A. I don't think so, but could be. Like, I don't know honestly. The biggest one is Tan 618. I just
Okay, sir.
Welcome.
Okay, now I request Dr. Professor Hemant Kumar sir, if he wants to add a few things and wants to interact with the students.
Thank you, Madam Radhika. Today I am very happy. Mr. Aryansh has expressed his astronomy knowledge in a very innovative way, and with the interaction like quiz and question answer sessions. And he explained so well in a mythological manner as well as as a astronomer our northern sky, in which we have Polaris, and we have asterism like Ursa Major, Ursa Minor, and all circumpolar constellations are there. And participants have asked so good questions and relevant questions, apart from few which are like recently asked question regarding black hole, bigger black hole, smaller black hole. In fact, in astronomy or in observational astronomy or in NASNI or the programs raised by Professor Rajinder Singh, Science Exploratory, we are talking about observational, that is especially naked eye observational astronomy. So we want to train our young enthusiasts for the our observable sky, in which we have our constellations, asterisms, planets, the sun, moon, and some prominent constellations, zodiac constellations and non-zodiac constellations. So otherwise, astronomy is a very vast subject. Only knowledge of sun and knowledge of moon is enough to explore throughout life. But basic astronomy we are focusing on. It is very good if students learn the names of stars of constellation like Ursa Major, like Big Dipper, Small Dipper, like Orion has prominent stars, can we learn the names of all these stars like Mr. Aryans told you about the Betelgeuse, Bellatrix is there, very bright star, Rigel is there, Ceph is there. Then in the belt, you have very bright stars like Mintaka, El Nilam. These are in the belt, very bright stars. So I will request all the students to start learning the names of constellations first. How many constellations are there? Around 88 constellations are in the sky. Entire sky is divided into 88 constellations. And constellations are different than asterisms. Asterisms may have different shapes, but constellations are officially have very rigid shapes, and they are divided into entire sky. Like you know about the Ursa Major, which is very different than the Big Dipper and Small Dipper. And therefore, in these sessions, we are focusing on the basic only. And students must be ready with the questions regarding, say, there was very good question like how the Polaris position tells us winter and summer, how it defines whether it is winter or summer. So the position of the Earth, because Earth is revolving around the sun, it is sometime at perigee and apogee. So depending upon that, in Hindu mythology, we say Uttarayan or Dakshinayan, like that. So now the Earth is going in Dakshinayan. That means अब हम दक्षिणायन की तरफ जा रहे हैं और अब हम धरती के सूरज के पास जा रहे हैं, लेकिन हमारा जो पार्ट है दैट विल बी, जहां हम नॉर्थ इंडिया में हम रह रहे हैं, दैट पार्ट विल बी अवे फ्रॉम द सन. So here we will get the lesser heat, lesser light. So we will feel winter here. But in Australia, in southern hemisphere, they will get the summer now. So it depends on the position of the Earth in the orbital, its orbital position around the sun, whether you will get the winter or summer. But you know, the axis, the North Pole is always towards the axis of rotation. So such kind of questions, you know, really motivate us to think about the motion also and position of, and we should know the Earth is moving so fast around the sun. Even then it takes 1 year to complete one rotation, one revolution. And it is, you know, per second it travels 30 kilometer per second. The speed of Earth around sun is 30 किलोमीटर एक सेकंड में जाती है धरती. तो ये भी एक अच्छा क्वेश्चन है और बच्चों को जानना चाहिए कि इतनी स्पीड से चलती है तब भी 1 साल लगता है. और हम हर जन्मदिन के दिन, जब हमारा जन्मदिन होता है, तो हम एक अगला टूर जो है सूरज की तरफ शुरू करते हैं. और पूरे 1 साल में जब हमारा नेक्स्ट बर्थडे आता है, तो हम एक ट्रिप पूरा करके आते हैं सूरज के चारों तरफ इस स्पेसशिप के ऊपर. हमारी अर्थ जो है, इट इज काइंड ऑफ स्पेसशिप. हम स्पेसशिप के ऊपर हैं और सूरज के चारों तरफ जाते हैं घूमने हर साल. और हर जन्मदिन के ऊपर हम एक पूरा ट्रिप पूरा करते हैं. तो जितने साल के हम हो गए हैं, इसका मतलब हमने उतने ट्रिप पूरे कर लिए हैं सूरज के चारों तरफ. तो कितना बढ़िया मजा आता है ऐसी बातें सुनकर. और माइथोलॉजिकल भी सोचना है और साइंटिफिकली भी सोचना है हर चीज. इसीलिए हमारा साइंस एक्सप्लोरेटरी जो है वो इसके लिए एफर्ट कर रहा है कि हमारे जो छोटे बच्चे हैं, न्यू इंथुजियास्ट एस्ट्रोनॉमर्स हैं, दे शुड नो द बेसिक अबाउट द एस्ट्रोनॉमी. और उसी सीरीज में मिस्टर आर्यांश ने आज आपको नेक्स्ट टॉपिक के बारे में नॉलेज दिया है. And on behalf of NASNI and Professor Rajinder Singh, Science Exploratory, I extend thanks to Aryansh on behalf of all of us for his efforts to share his vast knowledge which he has gained. He is a very good astrophotographer also. He has shown many images in which he has shown various constellations, and even I have seen that Andromeda also. That is a remarkable photo which we have seen today. With the camera, we get this much, but otherwise we can get better images. And I also extend thanks to Madam Radhika and all the staff members of Professor Rajinder Singh Science Exploratory, Nagpur, and all the students who took part today's session, and parents also who were behind these children and encouraging the children to know about the cosmos and participate in such sessions in spite of their busy schedule of forthcoming examinations, house examinations. I know house examinations are coming, but even then students are keenly participating in such sessions. So we are thankful to all of you, and that's all from my side. I am very happy with this session, and Madam Radhika will tell you the schedule of next session also, and see you all in the next session. Thank you very much.
Thank you
Thanks
so
a
much,
lot,
sir.
Hemant sir, for the kind words. Thank you.
Thank you, sir.
Thank you, Hemant Kumar sir. Thank you, Aryan sir. Now, for the formal vote of thanks, I would like to invite our biology teacher, Miss Ekta ma'am.
Thank you so much, ma'am. Good evening, everyone. I, Ekta Bagade, biology trainee at PRSSC, is here to formally present the vote of thanks. First of all, I would like to thank Mr. Aryan Saxena, sir, for this amazing session. Thank you so much for your valuable time, sir. Now, I thank Coordinator of NASNI, Dr. Hemant Kumar, sir, for collaborating with PRSSC and organizing such interesting session. Last but not the least, I thank all of you for participating and attending the session in a large number. I also thank all of the participants who have joined through various social media platforms. Thank you so much, everyone. Have a great evening.
Thank you so much, everyone. We'll meet on the next month's fourth Friday. That will be on 24th October. And see you all again with the same curiosity, and stay curious. Have a great night. Good night,
Thank
everyone.
you. Thank you. Good night.
Thank you, ma'am.
Thank you, everyone. Thank you. Bye bye. You guys, I have sent you my mail. You guys can mail me whenever you have any queries regarding anything. Okay. Thank you.